Hello and welcome once again to the Science Chef educational series on chemistry. This video is the first of a series on electrolysis. You will learn about the terms and mechanisms of the process. As stated earlier at the end of this lesson, you should be able to define the basic terminologies used in electrolysis, differentiate between strong and weak electrolytes with examples, and then describe the mechanism of electrolysis. Do not leave this channel, as we'll be right back after this timeout. Welcome back. The word electrolysis is derived from two words, namely electro, meaning current or electrons flow, and lysis, which means decomposition or breakdown. Combining the two words, we can define electrolysis as the chemical decomposition of a compound by passing direct current through its molten state or aqueous solution. The setup for electrolysis is known as an electrolytic cell or voltmeter and consists of electrodes, electrolyte, and power supply with connecting wires. A lamp is at times added to ensure that the connections are correct. An electrolyte is a substance that allows current to pass through it in its molten state or aqueous solution and gets decomposed in the process. It is divided into strong and weak electrolytes. A strong electrolyte ionizes completely in solution. Examples are strong acids such as tetraoxosulfate 6 acid, hydrochloric acid, triazonitrate acid, etc. Strong alkalis like sodium hydroxide, potassium hydroxide, and hydroxides of other group 1 metals, and salts such as copper 2 chloride, sodium chloride, copper 2 tetraoxosulfate 6, potassium bromide, lead 2 bromide, and so on and so forth. A weak electrolyte undergoes partial ionization or dissociation in solution. Examples are weak acids like ethanoic acid and other organic acids, and weak alkalis like aqueous ammonia, as shown on the screen. The single forward arrows show a reaction that goes to completion, while the double reversible arrows indicate an incomplete or partial reaction. Electrodes, on the other hand, are rods, plates, or wires through which current enters and leaves the electrolyte. They are the media through which electrons leave and enter the electrolyte. They are mostly metals except carbon graphite, which is a non-metal. Electrodes are generally divided into anode and cathode. Anode is electrode connected to the positive terminal of the battery, which makes it positively charged. It is the medium through which electrons leave the electrolyte, that is, A for anode and A for away. It is where oxidation occurs during electrolysis. On the other hand, cathode is the electrode connected to the negative terminal of the battery, which makes it negatively charged. It is the medium through which electrons enter the electrolyte. Remember, C for cathode, C for coming. Reduction occurs at the cathode. Next, let's look at the mechanism of electrolysis using sodium chloride. In the solid state, sodium chloride, being an electrovalent compound, is made up of aggregates of ions and cannot conduct electricity. But when it is melted by heating or dissolved in water, it undergoes dissociation to form randomly moving charged particles, which are able to transfer electric charges from one point to another. When the electrodes are connected to the power supply, the ions migrate based on the law of electrostatic attraction. The negatively charged ions, which migrate to the anode, are called anode ions, shortened as anions, while the positively charged ions, which move to the cathode, are called cathode ions and are shortened as cat ions. At the anode, the chloride ions undergo oxidation by losing one electron each to form chlorine atoms. Two chlorine atoms combine to form a chlorine molecule, liberated at the anode as a greenish-yellow gas. The electrons lost flow through the connecting wires from the anode to the cathode and lights up the lamp in the process, confirming the electrolyte as a conductor of electricity. At the cathode, the sodium ions undergo reduction by gaining the electrons to become deposited as sodium metal, according to the cathodic half equation. In order to balance the number of moles of electrons transferred, we multiply the anodic half equation by 1 and the cathodic half equation by 2, and then add the two equations and net off the number of moles of electrons lost and gained to obtain the overall reaction. That is basically the mechanism of electrolysis applied in the extraction of aluminium in our last lesson. If you are yet to watch the video, click on its thumbnail at the end of this lesson to watch it. Note that this explanation is based on the electrolysis of molten sodium chloride, in which there are only two ions, sodium ion and chloride ion, in the electrolyte, and there are no competitions at the electrodes. In our next lesson, we'll be looking at what happens when there are more than two ions in the electrolyte. Like this video and subscribe to the channel to stay notified when the video is published. Thanks for watching.